Tr.Mercy here again, taking you through kinetic theory of matter. Hope you will enjoy the lesson. It states that matter is made up of particles that are in a continuous motion. Now, since we said the states of matter are solid, liquid, and gases, now in the solid state, particles are closely packed together and they are held in fixed positions, and they vibrate in those fixed positions. In the liquid state, particles are not closely packed as they are in the solid. At least they have some degree of freedom. While in gases, particles are widely far apart and they can move independently. Now in the diagram, you can be able to see how particles in a solid are held together, very close together. While in the liquid, we have the molecules packed closely in a random fashion and they are free to move. While in the gases, the molecules are widely separated. They move at great speed. And also in that diagram, we are seeing some of the processes which a solid undergoes in order to become a liquid, and that is melting. A liquid changes to a gas by evaporating. Then from gas again to a liquid, we have condensation. And from a liquid to a solid, we have the process of freezing. Then we have the process of changing the state from solid to gas directly without passing through the liquid state, which we called sublimation. When a solid is heated, the kinetic energy of the particles increases and they begin to vibrate more vigorously. Now, this vibration continues until a certain fixed temperature when the forces that are holding the particles together are weakened, and they are weakened enough to allow the particles to change from the solid state to liquid state. Now, when a liquid is heated, on the other hand, the particles move more rapidly as the kinetic energy increases, and at a certain fixed temperature again, the particles gain enough energy to overcome the forces of attraction between them, and at that point, the temperature remains constant as the pure liquid boils at the boiling point. Now, the particles break free and enter the gaseous state. Now, when a gas is cooled, the particles lose kinetic energy, they slow down and easily attract each other to form a liquid, a process which we call condensation. Now, when a liquid is cooled, the kinetic energy of the particles continue to decrease, and as the particles take up fixed positions, then the liquid solidifies through a process known as freezing. Effects of heat on substances. So we have seen that all states of matter have their particles in motion. In the solid state, they vibrate at fixed positions. Now we want to look at what happens when we heat substances. For example, when we heat a solid. Now, it's important first of all to learn that substances found in nature are made up of matter. And we said matter is anything that has mass and occupies space. And we also learned earlier that matter exists in three interchangeable states, which are solids, liquids, and gases. Heating and cooling curves. Now, when a substance is heated, then we obtain a curve which we call the heating curve. And the curve obtained when substances are cooled is called a cooling curve. Now, look at the curve for the heating of impure water. You realize that Again, the temperature begins to rise as heating begins. So it rises until 100 degrees Celsius, but it does not boil at 100 degrees Celsius. Instead, it starts to boil at temperatures which are above 100 degrees Celsius. And it does not boil at a sharp temperature. Instead, it boils over a range of temperatures. So you can be able to see the range of temperatures at which impure water boils, which is above the boiling point of water. Region AB. The temperature rises steadily as naphthalene absorbs heat energy. The heat energy absorbed increases the kinetic energy of the particles and they vibrate more vigorously. So that is what is happening in region AB. Region BC. Between region B and C, temperature remains constant until all the naphthalene melts. This is because the heat energy absorbed is used to weaken the bonds holding the particles of naphthalene together. Therefore, there is change in state from solid to liquid. Region CD. Now looking at region CD, the temperature rises steadily as the liquid absorbs heat energy. The heat supplied increases further the kinetic energy of the particles, causing them to move faster. The rise stops at the boiling point. Region DE. Here, the temperature remains constant, though heating goes on. This is because the heat energy is used to break bonds to change liquid into vapor. The change of state from solid to liquid and liquid to gas can be reversed by cooling. During cooling, the gas condenses into liquid and finally the liquid freezes into a solid. And this now forms the cooling curve. Effects of impurities on melting and boiling points. Now, impurities decrease the melting point and increase the boiling point of a substance. For example, when you talk about a solid like ice, we know ice melts at 0 degrees Celsius. But if we contaminate it with something like maybe camphor or some water, then you realize that it will melt at temperatures that are below 0 degrees Celsius. On the other hand, water at sea level boils at 100 degrees Celsius. So if we add some impurity like common salt, that water will boil at temperatures that are above 100 degrees Celsius. Then something else about impurities is that the substance will no longer have a sharp melting or boiling point. In other words, it will have to melt over a range of temperatures which are below the melting point, and also it will boil at a range of temperatures that are above the boiling point. Now, normally, pure substances have a sharp transition temperature, i.e., melting and boiling points. Look at the heating curve of pure water. So we have the temperature starting at a level above 0 degrees Celsius, that is meant to be the room temperature, and it rises all the way to 100 degrees Celsius, where it stabilizes until all the water has boiled. So that is the boiling point of pure water, and that is representing a heating curve of pure water. Note that the boiling point is a sharp temperature. It's a temperature which is constant until all the water boils. Now, impure substances, on the other hand, melt at a range of temperatures lower than the boiling point, and also they boil at a range of temperatures higher than that of pure substances. So I have explained that earlier. Now, look at the curve for the heating of impure water. You realize that, again, the temperature begins to rise as heating begins. So it rises until 100 degrees Celsius. but it does not boil at 100 degrees Celsius. Instead, it starts to boil at temperatures which are above 100 degrees Celsius. And it does not boil at a sharp temperature. Instead, it boils over a range of temperatures. So you can be able to see the range of temperatures at which impure water boils, which is above the boiling point of water. Now, what are some of the applications of the effects of impurities on the melting point and boiling point? Are there any applications? Yes, there is. Now, salt is spread on rods to defrost them and clear the ice in temperate countries. Remember, we've said that impurities lower the melting point of substances. So whenever salt is poured on the ice in those countries, then it lowers the melting point of ice and it melts faster. And that is a positive thing because it makes it easier for people to live, to move around by lowering the melting point of the ice, and therefore the ice clears away. There are, however, long-term disadvantages of adding salt to clear ice because the salt accelerates rusting. Therefore, it leads to the corrosion and destruction of machinery in those countries where it is used to lower the melting point of ice. Now, let's move on to determining the melting point of a substance. Now, whenever we need to determine the melting point of a solid, then we have a setup like the one below. Now, in this case, we have the thermometer placed above the liquid, not inside the liquid. The reason is because the boiling of the liquid occurs on the surface of the liquid and not inside the liquid. That is why we do not immerse the thermometer inside the liquid. The safety bulb that is in the glass tubing of the thermometer allows the vapor formed to escape, preventing pressure from building up in the boiling tube, which may lead to an explosion. Now, flammable substances are not heated directly. Instead, we use a water bath or a sand bath to be able to heat them. Now, the altitude also affects the boiling point in that the higher you go, the lower the boiling point becomes. The reason is because at a high altitude, there is low pressure. The less the particles are compacted, making it easier to boil. So let me explain that point again. As you go higher, the boiling point reduces. And why it reduces is because up there is low pressure, and this low pressure makes the particles compacted, making it easier for them to boil. Methods of determining purity of substances. Now, so far we have discussed about the boiling and the melting points. So different substances have specific boiling points. For example, the boiling point of water at sea level is 100 degrees Celsius. So then the melting point of ice is 0 degrees Celsius. So we can use boiling and melting points to determine whether a substance is pure or not. Now, another method which we learned earlier is chromatography, whereby we said for a pure substance, it will only show one spot on a chromatogram. Then we can also use the density of a substance to determine whether it's pure, because different substances have different specific densities. Then we have refractive index, can also be used to determine the purity of a substance. And finally, pure substances can be. So we have some questions at the end of the lesson as usual. Question number 1. What is observed when the following substances are heated then cooled? Number 1, wax. Number 2, naphthalene. And number 3, iodine. Question number 2. The graph below shows the heating curve of a pure substance. Explain the regions AB, BC, CD, and DE. Question number 3. Study the cooling curve below and explain the regions AB, B, C, and C, D. Question number 4. Explain the criteria used in the test for purity of substances. Part B. State the effects of impurities on substances. And number 5. Classify the following substances as either pure substances or mixtures. Seawater, copper wire, a rock, distilled water, air, and oxygen.